All right, so welcome to our first student success seminar. And I set these seminars up because I realized over time that there are students who struggle with understanding how to approach an engineering course. And sometimes some of the study skills or the mindset that you need to really be successful in an engineering course, it's not always obvious, and it's not always a skill that you might pick up in a different course, like in an English course or a music course or a business course. So I wanted to start these seminars this semester so that we can start to talk about some of the skills that you need to have in your tool belt as an engineering student that are going to help you to be more successful in your classes. Now, this particular seminar is taking place with fundamentals of DC circuits. The people who are currently present on this call are in fundamentals of DC circuits, but as you go throughout your degree program, the things that I want to share with you now are things that are going to carry with you, especially as the program becomes more challenging. So my goal here is to sort of equip you with some of those tools to help you get all the way through to graduation. And what really inspired this was, for example, I had a student in my digital systems class last semester, fall 2020, who failed the midterm. And then he set up a meeting with me to discuss the midterm. And as we're going through the questions, I stopped and I asked him, well, did you review your homework when you studied for the midterm? And he said, no, I didn't even think about doing that. And that is a pretty critical study skill. So when I heard that, I thought, well, maybe there are other students who really may not just understand how to study for an engineering class and what they need to be doing. So that's where this all came from. So today we're going to start by talking about effective study habits that engineering students must have. And before I start, does anyone want to throw out any guesses or a hypothesis on what you might think is an effective study habit, specifically for an engineering class? Anybody have any guesses as to what will be on the list?
Like you said, reviewing homework.
Reviewing homework, yep.
Review the notes, lecture notes.
Yep. That's definitely on there. We're going to talk about
all
that.
The resources.
Yep, we're going to talk about resources. So you got two of the things I was going to talk about today. Any other guesses? Okay, so we'll go ahead and just jump right in because I don't want to take up too much of your time, but I just want to go over a few things. So you guys can all see that I'm sharing a slideshow, right? You can see my first slide?
Yes.
Awesome. Okay, so let's get started. So one of the most important study habits that you need as an engineer is you need to be able to figure out why you got it wrong. And by it, that could mean a homework question, an exam question, something in your pre-lab, something in your lab report that you might have lost points for, a measurement that you weren't able to correctly get on the breadboard in multisim, anything like that. So as an engineer, we're problem solvers. You're going to always be faced with different types of problems, and your job is basically to get to the solution. And part of that process is going to have to be to self-reflect and figure out why you got it wrong. So if you look at the picture I have on the screen, this is sort of like the problem-solving process that an engineer or an engineering student should be using. When you have a problem, you have to identify the problem, define the problem, explore solutions, take action, and then the most important piece is to look back. And what some students routinely don't do is they skip that last piece where they don't look back. So if it's not correct, as engineers, we've got to fix it. We've got to go back and figure out what happened and why. So part of becoming an engineer is constantly evaluating your work, going back and figuring out what must be fixed if something wasn't correct. So as a student, that's what your mindset should be. You should be evaluating your work as well, your homework, your pre-labs, your lab reports, etc. And for anything that is marked incorrect, go back and figure out why. Go back and figure out why. So every week, for example, you have homework, you have pre-labs, and I'm giving you feedback on those assignments, but I'm not necessarily giving you every single step of the answer. I'm pointing out where an error was made. What I want you to do as a student is say, okay, why wasn't that right? And what do I need to do to fix it? So for homework, that would mean looking at the homework solutions. For pre-labs and lab reports, that would mean looking at the rubric, because I'm going to point out on the rubric what might have been missing, things like that. When you're going back and you're looking at the assignments that you lost points on, for homework, that means redoing the homework. If you got 3 questions wrong out of 5 questions, those 3 questions you should go back and redo it until you can find the same solution on your own and you understand why it's correct. So if you're using the homework solutions online, the homework solution is just the final answer. It's the last piece of the puzzle. But what I want you to do is look at your homework answer, look at the solution. Okay, I got 50 ohms and the answer was 83.5. Why? Then I want you to go back through the notes, the textbook, the lectures, and start thinking about where your mistakes might have been and try your best to find it. So that might mean rewatching an entire lecture or a part of the lecture again. That might mean rereading the textbook. That might mean rewriting your notes. Most engineering concepts, especially as they become more complex, you're not going to understand and fully master the first time you hear it. Engineering is a game of repetition, reading that chapter over again, looking at those notes over again, redoing the homework over again until you get it right and until you can do it independently. So this should sort of be your process as you're approaching the homework solutions, and as well as like labs and pre-labs, going back and figuring out why. Now, I say all this because I'm trying to be helpful, and the idea here is not to impress upon you a spirit of perfectionism. And it's okay if you're looking at your homework and you just can't figure out what you got wrong. If you just can't figure it out, then the next step would be to start to use some of your other resources in order to figure out the problem. So that might mean contacting me, contacting the Open Lab, things like that. So definitely habit number 1, you have to go back and figure out why you got it wrong. So, like I was saying, if you cannot figure it out on your own, if you're not sure why something is wrong and you've gone through the lecture notes and the homework and blah, 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 the next thing is to use your resources. So as a student, here are some of the things that are available to you. You have me as your professor. You have the lab assistants in the open lab. You have your book. You have the library where you can check out other materials that are in line with our course. You can get our textbook isn't the only book that you can read on Ohm's Law, for example. There are other materials. So you can use the library. You can use other online sources, like there are plenty of YouTube tutorials. There's Khan Academy. There's MIT Open Courseware, things like that. How many people have heard of MIT Open Courseware?
I have not.
No? Okay, so
This is the first time I've heard of it.
Okay, so the nice thing about this is, you know, MIT, Massachusetts Institute of Technology, one of the top engineering schools in the country, has a bunch of their courses online for free. Lectures, notes, homework, solutions, and other resources, and they're all free. Basically, they're old, like say a course from 2002. They'll take all the videos from the professor who taught Digital Systems 1 in 2002 or 2008, and they just put the whole thing online for free. So great resource if you need additional help in understanding the information. So that's what I mean by using your resource, is to be able to look at all these things and figure out, okay, if I can't figure this out on my own, then I need to get some outside help, and these are things you can do. Another great thing is to network with your peers, start a study group, and work together to go through the material. So these are different ways that you can use your resources. So typically, if a student emails me after the midterm and they're worried about their grade and they're wondering, well, what can I do to improve my grade? This is one of the first questions I'll ask. Well, what resources are you using? What are you doing besides, you know, maybe watching the lecture once, turning in some homework, and then, you know, maybe that's about it. What else are you using as your resources? So if you're struggling, reach out to me, to the lab assistants, to your peers, or to the internet and get additional resources to help you learn that information. Does that make sense?
Yes.
Awesome. All right, so the next thing This is super, super important for engineers. Focus on understanding the concept, not memorizing it. Memorization is not something that works well in engineering, because at the end of the day, as an engineering student, what you're doing is you're learning different tools to put in your tool belt. You're learning how to use a hammer, you're learning how to use a screwdriver, you're learning how to use a saw. Then you go out into the real world and you have to know when to use what tool to accomplish a certain task. You've got to be able to apply it. So for an engineer, the way not to study is to try to memorize a bunch of things that were said in your lectures and your textbook on the homework, and then walk into an exam and hope that you can regurgitate some information. In this field, and definitely in this class, all of your exams are concept-based. They're not fact-based. I'm not going to ask you to memorize a bunch of facts to just regurgitate on an exam, and most of your other engineering professors won't either. They're all concept-based. In this class, that means your exams are free response. Any necessary references like equations or tables that you might need are provided, and you don't have your books or notes available to you. So when you take an exam, you're going to be presented with a scenario and asked to apply the concept. And simply trying to memorize, a formula or memorize a particular problem from lecture isn't going to help you if you didn't understand the theory behind that problem and how to apply it. So when you think about how to understand and not memorize, you want to make sure that you're looking at every homework assignment, every pre-lab, and every lab report, and being able to adequately explain that to someone else. So for example, if you can take each week's homework and explain why the answer is right to a friend or a family member, they don't even have to be an engineering student, but if you can confidently explain it to them, then you understand how to apply the information and you haven't just tried to memorize something. So when it comes to exams, you're not going to be given homework problems on exams, or you're not going to be given something, a problem you've seen before. What you're going to be given are problems that are based off the lecture and they're based off the homework, but it'll be a new scenario. It'll be a new environment, and you're going to be expected to apply the same concept that was taught in the homework, the lecture, etc. And it'll be a different scenario, but it'll be equivalent. So if you can apply the concept, then that means you can solve any problem that I throw at you. So focus on trying to understand the concept and why do we use Ohm's law in this particular way? Why are we using KVL or KCL? Why do we need a voltage divider? And why is the voltage divider set up this way? If you can understand those concepts, exams won't be an issue for you, and you won't feel the pressure of trying to memorize or cram a bunch of information right before the exam. Any questions on that idea of understanding, not memorizing?
Are you allowing a formula sheet for exams?
I will give you a formula sheet, yes.
Okay.
Yes.
Just curious.
So, yes. Yep. So I don't want the reason that you weren't able to figure out a question was because you couldn't remember how, the formula for power or something like that. Because
Sure.
ultimately that's a small thing. What I want to know is, here's the formula for power. Can you use it correctly in the right application? That's what we're looking for as engineers.
Right.
So yeah, you're going to be given any necessary references for the exam.
Thank you.
Any other questions on the idea of understanding and not memorizing? Has anyone ever taken another class that might have had a similar style where it was more about understanding the information and not just memorizing facts?
Photonics.
The intro course.
The intro course? All right.
Yeah.
Any non-engineering courses you've taken that might also require this idea?
Forgot the name of the class. Hold on.
Or what was the subject of the class?
Yeah, I forgot completely.
I took a philosophy class. It was quite similar to this.
Okay. So you had to take an idea and then be able to apply it to a new situation?
Yeah.
Okay.
There was an English class I took
Okay.
that was all about understanding certain things instead of just memorizing it.
Yes. Yep. So the same idea is going to apply in this class. So keep that in mind. And like I said, I'm not just talking about this class. I'm talking about every engineering class that you take, especially as you get closer and closer to graduation. It's going to be more and more about what concepts can you apply. And it's not at all going to be about what you can memorize. All right, let's move on. So a few more tips on the best way to focus on understanding and not memorizing. Make sure you're attending class without distractions. And that can be hard when you're taking an online class. And if you're watching the YouTube video on your phone, on your computer, these are all distraction devices. We're now, our devices are now designed to distract us. So as best you can, when you're watching the lectures, make sure you're doing this distraction free. Make sure you're taking detailed notes. The lecture notes are a jumping off point. So I know there are some students who have turned in lecture notes from last week and they've written way more than the lecture notes that I've provided. And that's great. That's awesome. That lets me know that you're thinking about things and trying to pay attention to other details. So make sure that you're using the lecture notes as a starting off point, but feel free to add more to them if there are other things that you think you need to remember. Keep in mind that physically writing things down helps your brain to retain information. So watching is great, but if you're watching and then writing down what you saw, your brain is working harder to retain what you just heard. And then make sure you're asking questions about things you don't understand when it comes to the lectures. You can get on Canvas and send me a quick message if there's something from the lecture that didn't make sense. It's best to ask those questions early before you get to the homework or before you turn in the homework and get it all wrong, things like that. So ask questions early if you don't understand. Make sure you're doing the homework after you review your notes from the lecture. So watch the lecture, read through the notes, ask yourself, how much of that did I understand? If you're feeling at a good 80, 90%, start the homework. And then, as we talked about before, self-correct every homework problem that was marked wrong. That's how you learn how to understand and not memorize, by going back and correcting your work. And then, of course, I'm putting on the screen a list of things that you might have to do in order to correct your homework. Everyone's going to be different. Some people are going to go back and immediately see their mistakes. Some people are going to have to work a lot harder to find it. So how much you might have to do to fix your mistakes is really dependent on how you learn. But these are some of the things you should be doing to self-correct your work.
I have a question about homework.
Yes.
We have to like physically write in the homework. Is there a way I can do it like digitally using a stylus? Is that okay?
Yes. Perfectly fine. So if you have a tablet and you have a stylus and you want to download the PDF and just write on that, you could save it right as a PDF and upload it back to Canvas.
All right, then. Thank you.
Yeah. All right. So when it comes to focus on understanding and not memorizing, you just make sure as you're heading into that midterm exam and you're heading into that final exam that you feel confident you can apply the information presented in class to a new scenario. And the best way to do that is just before a midterm, after you've finished all your studying, probably a day or two before, pick some extra problems from the book, problems that weren't assigned, problems that you haven't seen before, and try to solve them. And the nice thing about this class, you have multi-sim. Every single question in the textbook is just analyzing a circuit. You can go build that circuit in multi-sim. And let's say that you had to find the voltage and the current for every resistor in a series parallel circuit. Maybe that's something you'll need to do for the first midterm. Go into multisim, build a series parallel circuit, and add the measurement tools. So you can get the current and the voltage in multisim and then go do it by hand and see if they match. If you can do it by hand, then you know what you're doing. And that's an easy way to have the right answers right at your fingertips. So use multisim to your advantage. That's definitely a tool that students don't use enough of. So keep that in mind. All right, and then the last tip that I have today, and this is a big one, it's procrastination. And this is a judgment-free zone, but if you're willing to share, how many of you are guilty of procrastinating? If you're if that's you,
I think
yeah,
we're all guilty.
you think you're all guilty?
Yeah.
Yeah.
Put on my face.
Yes, procrastination. So this is actually one of the biggest things for me. And if you look at the picture I have on the slide, I mean, it kind of shows exactly what happens when we procrastinate. You have this false sense of security that you have time. I'll do it now. I'm going to relax, hang out, have some fun. It's not due till next Tuesday. I've got plenty of time. And then you get into a phase of laziness where it's like, maybe I should start, but I still have 5 days left. I could push it. And then we make excuses for ourselves, like, I'm too tired, I've got other things to do, I don't feel like it, I'll have more adrenaline if I wait to the last minute. And then you get to the stage of denial where you think you still have time, but you really don't. You've already run out, and now you're in a crisis of trying to rush to meet a deadline because of procrastination. So engineers can't procrastinate. It just doesn't work for us. And I'm going to explain why. First of all, in engineering courses, concepts are more challenging and they take more time to learn. It's just a lot of things you just are not going to absorb in the first 10 minutes that you hear it. So you need time to be able to go over the material more than once. Within engineering, the assignments are meant to challenge you. They're meant to push you. That means you need time to think through a problem, try something out, perhaps get it wrong, try that homework again later before you turn it in. You need time to look at the question and say, wow, I have no idea what that question is asking for. So I guess I better go read the book or rewatch the lecture or email the professor or get online with a tutor. All of that takes time. So if you're starting your homework at midnight and it's due 7 hours later and you're just now realizing you don't know what's going on, the resources that are available to help you aren't going to be there for you at the last second. So you need time to be able to reach out and get help if you need it. You can't do that if you procrastinate. Then another thing with this class and future classes, your lab work takes time. And you may not build your circuit correctly the first time. You might need time to get a lab assistant, seek help. You might blow the fuse on your multimeter trying to measure current, and you might need a new fuse. You can't get a new fuse at 2 o'clock in the morning. So another reason not to wait to the last minute is the fact that your labs take time, and you need time to also not get it right the first time and to try again. All of that should be going through your thought process as you're thinking about how to plan your week and how to get the assignments done for your classes. With engineering, and we're going to talk about engineering failure next week, like a whole lot, but just sort of as a heads up, engineers are failures who eventually get it right. You're going to fail. You're not going to get it right the first time, whether that's a homework assignment, a lab, whatever the case is. You need time to fail, reflect, and try again, often repeatedly. And like I said, this is your first level course in engineering, so this may not necessarily apply to you right now, but you're going to get to a class closer to graduation or 2 or 3 classes that are really going to push you, and you're going to need that time to fail, reflect, try again. Fail, reflect, try again. If you're procrastinating, you don't have time to do that, and you're rushing through your assignments, you're turning in work that isn't correct, and you're not giving yourself time to actually learn the material. And then these are some of the effects of procrastination. You're not as productive, you're wasting time, you're causing yourself stress, anxiety, or self-deprecation. You have a weaker understanding of the subject material. So like we just said, focus on understanding and not memorizing. How can you understand if you're rushing through everything to get something done? You can't truly understand it if you don't give yourself time to absorb the information. Poor grades, missed opportunities, and you're not working up to your full potential. So these are some of the things we want to think about before we take the step of saying, I'll do it later. I'm not going to worry about it. Can anyone else think of anything else we could add to the list for effects of procrastination? Are there any positive effects?
No.
Well, does anyone enjoy the adrenaline rush? I know there are some people who like the adrenaline rush of saying, I only have 5 hours to knock this out. Does anyone like ever feel like that?
It feels exciting.
Feels exciting?
Depends on the class, really, and what it is I'm
Yeah.
doing.
Yeah, it's not the same for everything.
Yeah.
It's
Me
not gonna
sometimes.
work here when you have 5 different assignments due on the same day.
That's for sure.
Right. So that's a big thing to consider. And the model for this class of homework, lab report, pre-lab every week, that's going to be in AC circuits, digital 1, digital 2. Like it's sort of a model for the EET program. So you're going to see the same sort of system. I don't know if every professor has lecture notes, for example. And some professors will do a weekly quiz instead of homework. But in general, you're going to have quiz or homework every week, lab, pre-lab every week for most of your engineering courses. So you've got at least 3 assignments. Some professors might require you to read the textbook before coming to class. So you're going to have, 3, 4, 5 things you have to do every single week in order to stay on pace. So procrastination definitely won't work if you are waiting until the night before to start watching the lecture. Then you got to do the notes, then you got to do the homework, then you got to do the pre-lab, and you got to do a lab, and then you got to do a lab report. Doesn't work, right? It just doesn't work. So if you are a procrastinator, I'm begging you to start to try to change that and do it now while you're in a first year course. Because if you build those habits now, as the courses get harder, then you have the system in place to tackle those more challenging subjects. So here's some of the tips that I have for trying to get better with procrastination. Make sure you're organized, read the syllabus, make a plan for completing the assignments, and use a productivity app. There are some really great apps out there that can help you to stay accountable. So for example, if you need that push or that reminder to, get homework done by a certain time or watch the lectures by a certain day of the week, you try and look at a productivity app to help you do that and to track your progress. Make sure that you're setting simple and achievable goals. One of the things that procrastinators do is they set an impossible goal of trying to power through 5 assignments with 4 hours left to turn everything in. Like it's impossible. You can't do that. But if you break things down into smaller tasks, it doesn't seem as daunting. And I'm going to show you an example of that in a second. Make sure you're getting rid of distractions so that when you are working, you're being productive. So try to remove things that are going to cause you to get sidetracked. If you're working on homework, lecture notes, lab, put your phone away, turn off your notifications, turn off your ringer, whatever you need to do to make sure that when you are working, it's productive. So you're not wasting time. You could very easily spend 4 hours on one homework assignment if every 2 minutes you're responding to a text message, responding to a tweet, reading an email, etc. So try to remove the distractions that are around you. Question? Oh, okay. And then another thing that might work for you is to take planned breaks. So rather than waiting into the last minute and then trying to push yourself for 5 hours straight to finish all of these assignments, try to work for 50 to 90 minutes a day. Or if you're going to do more than that, take a 10 to 30 minute break in between, because at a certain point, you're just going to get mentally exhausted from trying to power through a whole lot of things all at once. And then try to use some incentives, like find ways to reward yourself after completing a task. So if you're a procrastinator who really doesn't like the idea of starting an assignment 6 days in advance, try to find an incentive. Okay, I really don't feel like doing these lecture notes today, but I'm going to watch the video, I'm going to do the notes, and then I'm going to, sleep for 30 minutes, or I'm going to watch Netflix for 30 minutes, or I'm going to eat, whatever it is, but try to give yourself an incentive to get yourself excited or motivated enough to get the task done before the time is running out. So here's my advice for this class. You have 4 assignments due in a typical week: your lecture notes, your homework, your pre-lab, your lab report. And for this class, everything is due Tuesdays by 7 a.m. If I were a student and I was trying not to procrastinate, this might be what my week looks like. Notice that the week begins on Wednesday. So I put the asterisk here to show that, okay, this is where a new week of material begins because your due dates are Tuesdays, right? So let's say each Wednesday, you watch the lecture video, complete the notes. That should take you about an hour. On Thursday, complete the homework, complete the pre-lab. Okay, pre-labs are typically shorter, homework is a little bit longer, but you know that should average out to about the time you see on the screen. And then on Friday, do your lab experiment, start your lab report. Not finish it, but maybe you start, getting your pictures put together, maybe you start working on your discussion, do the experiment, start your report. Saturday, Sunday are off. On Monday, finish your lab report, turn it in, and then double check that everything that's due Tuesday by 7 a.m. has been actually submitted to Canvas. And that could be your typical week for this class. So you'll notice that there are 3 days here that are completely open. And those 3 days might be to rework your homework, redo lab experiment, catch up if you were sick on Thursday and you actually didn't do anything, or maybe you're taking more than one class. Those might be days that you would spend on another class. But this is just an example of like how you could structure it so as not to procrastinate. For example, I had a student last semester who was trying to do all of his assignments on Thursday. And he said, well, I couldn't work. I couldn't, hang out with my kids. I was doing everything on Thursday. And I asked him, well, why? And he said, well, I just assumed that the lecture videos weren't available ahead of time. And I said, well, all of the lecture videos are on Canvas. All the homework is online. Everything is open. And he had no idea that he could have spent a little bit of time each day versus stressing himself out for the entire semester by trying to do it all on one day. And then that affected his performance on the exams because he wasn't really retaining a lot of the information and he wasn't learning how to apply it. He was learning to rush through assignments and try to get them all done by a due date. So this is my sort of sample for how you might avoid procrastination and break up your work to about hour to an hour and a half tasks, 4 days a week. Any thoughts on this? Is there anyone who finds this helpful, or would you change it? Would you do something different? What do you think?
I'd put the lab experiment on Thursday, just to save some more time.
See, that's a good point. If you're starting the lab on Friday, the open lab closes at 5. And the open lab is available on Saturdays, but the lab manager is not. So if you needed a component, if something happened with your multimeter, then you really only would have Monday to get that fixed. So that's a good point. And you can totally do that. Like you can do the lab first if you want to, before you do the homework. You could totally swap it. So this is, again, just a suggestion. I want you guys to look at it and figure out how might I adapt some of this into my own study routine. So any other thoughts on whether this would work for you, or if it wouldn't work for you, why not?
Some of us have to work around, a job. So I usually do I have random days off. So I just do all my coursework on the days off.
Mm-hmm.
So that tends to work for me.
Yeah, and that's totally understandable. Everyone has their own schedule, their own list of responsibilities. If your work schedule and the due dates for the class are set up in such a way that you can't avoid, like maybe your only day to work is Monday, well, you got to do what you got to do. I would suggest, do you even have 15 minutes a day? Could you take the 15 minutes that you might spend on social media or watching a show and just start the lecture? Even if it's just 15 minutes a day, it takes something off the plate so that you're not heading into the due date with a long list of things to do and feeling that pressure of having to get it all done. So that would kind of be my advice for that.
Yeah. Thank you.
Any other thoughts? Okay, so I believe that's all I had for today. Yes, that's it. That's all I have. So I'm going to give you sort of a teaser. Next week, we're going to meet at the same time, Monday, 11 a.m. for 30 minutes. And the second seminar is going to be talking about your engineering mindset. And it's not a failure, it's an unfinished success. That's really how engineers have to think. So we're going to talk about engineering failure. We're going to talk about the mindset, the way you need to think about becoming an engineer in order to actually become one. So that's next week. Is there any questions, comments, feedback from anything we talked about this week?
I think it's all really clear.
Okay. Did you guys find this helpful? Did you learn anything new? Did you maybe start to think about how you might change a study habit to be more effective in your classes?
Yes, definitely helpful. Thank you for
Yeah.
keeping an eye out for us.
Cool. All right, good. Well, so the next thing that you're going to do is you're going to take a short quiz over what we just talked about, and you're going to write a short reflection. These assignments are not meant to take a lot of time, but it is just to verify that you either came to the meeting or that you watched the recording. And it is part of your grade, so you get a few points for it. It should be easy points for most of you as long as you were here and listening to the discussion. And like I said, we'll meet again next week for part 2.
Thank you, Professor.
All right.
Thank
All
you.
right, you guys have a good day.
Thank you.
Thank you
Appreciate
very
it.
much. Bye.
Bye.